research was conducted on the amount of training for 5K and the time a contestant took to run the race. The researcher recorded the number of miles during training, a 1-month period, and the time to complete the 5K. The results are below. So I have the results here on an Excel sheet, and I'm going to compute the correlation. So I'm just going to say correlation. It says array 1, array 2, which means it doesn't matter which one is X and which one is Y. So I'm just going to choose the first one and the second one. And I have this as a correlation. Sometimes, the numbers don't appear to be complete. So don't just type. I would say copy and paste instead. And if you make the cell bigger, you can see all of the numbers. That is one idea. So this is the correlation. I'm going to say this is basically rho or R. Here. And then I want to find the slope for this equation, for the regression equation. So I'm just going to say M for the slope, which is going to be equal to slope. And then double click the function. It says here the known y's and then the known x's, which in this case it matters which variable is the y and which variable is the x. The x is the independent variable and the y is the dependent variable, and in this case the mile trained is the independent variable and the time it took for that training is the dependent variable. So x is the mile trained and y is the time. So it says here known y's, so I'm just going to select the y's first, and then comma, I will select the x's next. And that is the answer I am getting here. And then I'm going to try to find the y-intercept. So I'm just going to say b here, and it's equal intercept. Same, the known y's, so I'm going to select the y's first, and then comma, I will select the x's next. And that is the number I am getting. Now you're going to find, you're going to interpret the y-intercept here. The y-intercept, the meaning of y happens when the value for x happens to be 0, which is in our case, if the value gets to 0, which is the mile trained is 0, we expect the trainee to finish the 5K race in y-intercept amount in minutes. That is 34 minutes approximately. 34 minutes approximately, which really doesn't make sense given these numbers. However, as you can see here, these numbers with the times to finish are not following any linear model, so to expect that is not far-fetched. Then you're going to find the predicted time in the 5K if someone trained 45 miles. So what you're going to do, you're going to remove the x from the previous equation, replace it with the number 45. So don't use the round numbers. So you're going to say equals. You will take the first value, which is the slope, times the 45, which is the amount for x, or the value for x, and then plus the b value. The b value, we computed that here, so I'm going to click on it, and that would be the predicted number. And then to find the residual for the if the trainee trained for 106 miles, you're going to compute it again. So you're going to compute the predicted value again. So you're going to say predicted here, and you're going to say equals the slope times 106 plus b. And then you will find the actual value, which is this value right here. I'm just going to try to highlight it. So that is the actual value from the table that corresponds to 106 miles. And you're going to subtract the predicted value from it. And that is what gets you the residual, which you can tell it's going to be negative because this number is smaller than the predicted value, which is In linear regression, we say the model overestimated the response variable because the actual value is below the predicted value, so it overestimated the response variable in this case. So the model is overestimating.